abstraction layers there, dude. That's awesome. Mhm. So the task requires, so it's generation start. The task requires implementing a stack with constant time operations, including finding minimum. To achieve O1 for getting min, we need to maintain a second stack that keeps track of minimums. Each time we push, if the value is smaller than current min, we add it to the min stack. When we pop, if the popped value equals current min, we also pop from min stack. Generated, so this is the Python code, and generation. And that's because I'm not going to explain it. And evaluation end. Um, Valuation start status needs improvement. So the feedback, okay, cool. So you can see because we asked it to format like that. While the implementation is generally correct and achieves O1 time complexity. Valuation end. Okay, generation start. Based on the feedback, I'll improve the implementation by adding proper error handling with expectations, including type hints and doc strings. Adding input validation, maintaining O1 time complexity for all operations. Operations. Generate, so from typing import, okay, min stack, okay, it's budget code and generation. Okay, so nothing about code execution, um, which is too bad, but I just think it's gonna take some time. We're gonna find a solution. Let's watch the orchestrators. I want to go through here because I just want to learn from people that are way ahead of me in this stuff. In this workflow, so this is the orchestrator workflows, and actually I want to go ahead here and say my notes here. It's a good cookbook. I think that was the evaluator optimizer. In this workflow, one LLM call In this workflow, a central LLM dynamically breaks down tasks, delegates them to worker LLMs, and synthesizes their results. When to use the workflow, this workflow is well suited for complex tasks where you can't predict the subtasks needed. The key difference from simple parallelization is its flexibility. Subtasks aren't predefined, but determined by the orchestrator based on the specific input. From typing, import dict, list, optional, okay, parsing. Parse XML tasks into a list of task dictionaries. Then this flexible orchestrator breaks down tasks and runs them in parallel using worker LLMs. So initializes the prompt details here. Format a prompt template with variables. Process tasks by breaking it down and running subtasks in parallel. Example use case, marketing variation generation. Orchestrated prompts analyze this task and break it down into 2 to 3 distinct approaches. Task. Return your response in this format. Explain your understanding of the task, and which variations would be valuable. Focus on how each approach serves different aspects of the task. Horrible, right? A precise technical. These things are interesting.
You know, it's something that truly exists in all of us. It's very simple. This is what I believe, and I'm willing to die for it. Yeah. Period.
Um, let's copy this link here. Prompts, courtesy. All right, let's just make sure that I got a link there. Worker prompt here. So return your response from this format. Orchestrator. So orchestrator, flexible orchestrator, orchestrator prompt, worker prompt, worker prompt. Okay. Result orchestrator process. Write a product description for a new eco-friendly water bottle. Context, target audience, environment.